Today, I am going to solve a problem on the stereochemistry of Aldol reaction. You can find this problem in CSIR NET exam 2012 June. Here is the problem. This chiral aldehyde reacts with compound B to give this beta hydroxy ketone. What is the structure of B and what type of facial attack takes place? The given options are here. They are given lithium enolate, but the stereochemistry it is E here, but here it is Z. Here it is Z and here it is E. Which one? Then the facial attack, whether it is Re-Psi or Re-Re or Psi-Psi. First, let us try to understand what is the reaction takes place here. It is nothing but Aldol reaction. So a new bond has been formed here. Since it is addition reaction, I write like this. This bond comes back. This goes here. So I get this aldehyde and for the time being, I write like this because I have no idea about the stereochemistry of this enolate. Generally, the formation of enolate, it depends on three factors. First one, solvent, temperature and base. They decide what enolate will be formed. But in this problem, they have not mentioned anything about the solvent or temperature or base. That means there is one more clue in the problem which decides the stereochemistry. That is nothing but steric hindrance. They have given ethyl tertiary butyl ketone. This tertiary butyl group, it has been attached because this decides the stereochemistry of enolate. If you look at this enolate, this CH3 and this tertiary butyl, they are in the same direction. Because of that, the steric hindrance will be more. So this is not favored. So this E enolate, because 1, 2, 1, 2. So the stereochemistry, it is E. E is not favored because of steric hindrance. So this also E. So this also not favored. Second and third, they are Z enolate. And there is no steric hindrance between the bulkier tertiary butyl group and methyl group. So this is more favored. We can also predict this Z enolate is involved in the reaction based on the transition state. I will go to that later. For the time being, remember steric hindrance decides the enolate. Now, what do you mean by Re and Psi? Generally, this nomenclature, it is used sp2 trigonal carbon with 3 different substituents. For example, I go for aldehyde like this. This carbon, it is sp2, so it is trigonal carbon. And it has 3 different groups or HO. This thick line and thin line, they represent that R is facing towards us like this. Hydrogen is going down. So the molecule is placed like this. R is coming this side and H is going down. And the CO is in the plane of the paper. Now, If I view the molecule from here, R group is like this, hydrogen is going down. So what I will see is, on the top I can find oxygen, towards my left there will be R group, towards my right there will be hydrogen. That is oxygen, towards my left there will be R, towards my right there will be hydrogen. Now I give the priority, the first one for oxygen, second one R, third one hydrogen. Since it is anti-clockwise direction, so this is called psi. Don't confuse with R and S. This psi is used in trigonal carbon, and this is not optically active. But if you give S configuration, that compound is optically active. So if the nucleophile attacks the aldehyde from this side, we call it psi phase attack. So this phase, it is psi phase. Okay, if I view the molecule from here, then towards my right there will be R, and towards my left there will be hydrogen, on the top there will be oxygen. I give priority now, 1, 2, 3. So it is clockwise. So this is called rephase. If the nucleophile attacks from this phase, then that is called refacial attack. Attacks from here, that is psi facial. In this problem, we have trigonal aldehyde and this enolate also trigonal. So this enolate, already we have seen that it is Z enolate. So this carbon attacks the aldehyde. So what about this phase, whether it is rephase or psi phase, and which phase of aldehyde is attacked? For the product, you can see that the alcohol, it is thick line. That means the enolate attacked from the bottom. So that means that we have to view the molecule from the bottom and we have to assign configuration. So since the OH is coming towards us, the nucleophile would have attacked from this side, back side. So what phase is that? If you view this from the bottom, 1 will be there on the top, 2 will be towards your right hand side, 3 will be towards your left hand side. So that is clockwise direction. So rephase. In the enolate, since it is Z enolate, this phase attacks the aldehyde, not back side. So comes back and this attacks the rephase of this aldehyde. So this phase is 1, 2, 3. It is psi phase. So the facial attack, it is re and psi. Now let us go to the given option. In that, re psi is there. Re, it is wrong. The re psi is the correct answer. Suppose if I go for re psi attack, facial attack, will I get this product? You may know that Aldol reaction goes through 6-membered cyclic transition state. So I draw the 6-membered ring. So I make it somewhat big so it will be clearly seen. 6-membered chair transition state. In this, whatever atom I am going to place here, that is the front, and this one it is back side. I place the aldehyde like this. So aldehyde is in the front. If the nucleophile, if it attacks here, then OH will become thick line. And this is the enolate. Here tertiary butyl group is there. Enolate, lithium ion. So I have placed the enolate and aldehyde like this. So there is interaction between this oxygen and lithium, and a new bond is formed. Now you can see here the phase that is attacked in aldehyde is 1, 2, 3. So it is as such, if you view from here it will be S, but if you view from the back side it will be R. Now I have to place this methyl group here or here. If I place like this, that is in the equatorial, that is trans enolate, E-enolate. If I place like this, then this methyl and O, they are in the same direction, that is Z-enolate. Already mentioned, Z-enolate is more favored for steric reasons. So I go like this. Now this falls here, this double bond attacks here. So what I get is here, hydrogen is here, then tertiary butyl, CO. You can see here this CH3 and this OH, they are syn. CH3 and OH, they are syn. The given problem, OH and CH3, they are syn. This CH3 and hydrogen, they are trans. You can see that here, this CH3, the hydrogen, here they are trans. So if I place the methyl group in the axial position, then only I will get the desired stereochemistry. If I place here, if the methyl group is here, the equatorial, hydrogen will be here and CH3 will be here, OH, I will get a compound like this, in which this OH, CH3, they are trans. So this is not possible. In the problem, they are given, they are cis. That is possible only in this. Axial and equatorial, they are cis in 1-2 position. So this enolate is involved in the reaction, not the another one.